Hi everyone, welcome to our class on arguments. Finally, we introduce arguments, which is going to be the main topic of this class. Okay, so before we get there, let's get a quick refresher. We spent a lot of time in the past lecture videos and reading materials analyzing statements, and in particular figuring out when are they true. So we saw that simple statements are simple, and so they're true just when the predicate correctly characterizes the object. Right, remember Piper, the dog. Piper is a dog is true just if Piper is a dog. What about complex statements? When are these complex statements true? Well, this is harder, and that's why we saw in the past videos we introduced truth tables, and these allow you to determine the truth value of a complex statement based on its more simple components. Okay, so why are we focusing on statements, you might ask? Well, remember that the goal of this class is to give you tools to distinguish good from bad reasoning, right? And we call this the bad reasoning detector. So how do we do this? Okay, the first thing to notice is that good reasoning is done with good arguments. So suppose that I'm trying to convince you that sugar is bad for you, right? I'm trying to tell you that, well, you shouldn't consume too much sugar in a day, it's really unhealthy. A bad way to reason would be, look, if you disagree with me, then I'm going to punch you in the face. That would be terrible reasoning, even though it might perhaps be effective. A good way for me to convince you is to give you convincing reasons, or good reasons. And notice that here, I would have to give you reasons for a particular claim, or a statement, namely, sugar is bad for you. Okay, so let's get a little bit deeper into this and ask, well, what is an argument? Right? I've just left it a little bit intuitive now. And what does it mean for this argument to be good? And this is what we're going to concern ourselves in this lecture. Okay, so let's start at looking at arguments. This is a definition. An argument is a string of statements, one which is a conclusion, which is supposed to follow from all the others, which are called the premises. And from the chapter of the reading, we saw that the conclusion states the point being argued for, and the premise states the reason being advanced in support of the conclusion. So note that the conclusion is a statement that we're trying to convince you of, and to convince you of that statement in an argument, we're giving you a bunch of other statements, and these statements are called the premises. Okay, it always helps to look at an example. So suppose we have the following example. All cats in Irvine are indoor cats. Piper is a cat in Irvine. Therefore, Piper is an indoor cat. Now, stop for a second and think, is this a good argument? To figure out if this is a good argument, we have to figure out what are the premises of this argument and what is the conclusion. I recommend always looking for the conclusion first. And in this case, I've made it easy for you, therefore, Piper is an indoor cat. So Piper is an indoor cat is the statement that this argument is trying to convince you of. And the premises, which are the reasons for you to believe the conclusion, are two statements, namely, all cats in Irvine are indoor cats, and Piper is a cat in Irvine. So I'll give you a second to think about whether you think this is a good argument. What makes it a good argument, and what could potentially make it a bad argument? Okay, let's look at another one. This is the argument. No tree trunk is pink. There is a tree in my backyard. Thus, that tree is not pink. Okay, what is the conclusion of this argument? Okay, again, I've made it kind of easy for you. So the conclusion is that tree is not pink, and the premises are that no tree trunk is pink, and that there is a tree in my backyard. Let's look at another one, just to make sure we understand what the form of arguments, or at least get an intuition for them. So suppose that I'm playing a game of poker, and I see that I have the Queen of Hearts in my hand. Hence, I conclude, my opponent doesn't have the Queen of Hearts in her hand. What are the premises and what are the conclusions? Well, the conclusion is that I've made is that my opponent doesn't have the Queen of Hearts in her hand, and the premise and the reason for this is that I have the Queen of Hearts in my hand. Right? So in the previous example, I gave you examples with two premises, and this one there's just one premise. And usually you can find and discover conclusion with some filler words, such as hence, or therefore, or thus, or because. And I just want to show you that you don't need to have an argument in this form for it to be perhaps a good argument. So in the sentence, she doesn't have the Queen of Hearts in her hands because I have it, that's also an argument. Where's the conclusion and where's the premise? Okay, so here it is. So note that the conclusion came first in this sentence. She doesn't have the Queen of Hearts in her hands. That's a conclusion. And the reason why? Well, because I have it. Okay, so the conclusion doesn't have to be stated last. And it is a skill. In good arguments, you'll immediately find the conclusion, but it is a skill to parse out arguments such that there are premises and conclusions and that these are very clear. So in this class, we're interested in how good an argument is. But the word good has been used quite loosely. So what could determine this goodness of an argument? Let's look again at the example of the cats in Irvine. So it starts like this. All cats in Irvine are indoor cats. Piper is a cat in Irvine. Therefore, Piper is an indoor cat. So again, take a second here to try to see what could make this argument good. Well, one consideration would be, are the premises true? Is it true that all cats in Irvine are indoor cats? And is it true that Piper is a cat in Irvine? Are these statements true? But this isn't the only consideration that we might care about. And in fact, it's not even the prime consideration that we'll care about in this class. What we care about is the logical relationship between the premises and the conclusions. So how that works is that we're going to say, assuming the truth of the premises, so let's assume that all cats in Irvine are indoor cats, and let's assume that Piper is a cat in Irvine. Does the conclusion follow from the premises? And this is a different question of asking, are the premises true? Because we're assuming that they're true. And so is it the case in this example that Piper is an indoor cat if the premises are true? Well, yeah, it is, right? Because we're saying all the cats in Irvine are indoor cats, and Piper is one of these cats. So since she's one of these cats and all of these cats are indoor cats, then Piper is also an indoor cat. So let's look at another example which will convince you that really what we don't care about is whether the premises and even the conclusions are true. What we care about is the relationship between the premises and the conclusion, the logical relationships between them. So look at this argument. The 2024 Olympics are held in Paris. UC Irvine is in California. Therefore, 22 is an even number. So let's look at the truth of each of these statements. The 2024 Olympics are held in Paris. That statement is true. UC Irvine is in California. That statement is also true. Therefore, 22 is an even number. That's also true. But really, this is not a good argument, right? Intuitively, there seems to be a fundamental lack of connection between all these statements. So in evaluating an argument, right, you might be interested in the question of, are the premises true? Or the question of, assuming that the premises are true, does the conclusion follow? Now, I said that we're not so concerned about whether the premises are actually true. Why? Well, because examining whether the premises are true, this is in the domain of empirical science, right? What logic can't do is look at a bunch of statements and tell you, oh yeah, that's actually true in the world, and that's not true, that's true, that's false, etc. Logic cannot do that. That's what scientists do. Now, what logic can do is say, look, bring me statements, and what I can tell you is if you put them in a certain way to make an argument, I can tell you if that argument is good or not. So it's the second question that we're going to be really concerned with, namely, assuming that the premises are true, does the conclusion follow? Now, you might have noticed that we're using this word follow somewhat ambiguously. And actually, there are two notions of follow that we're going to explore in this class. Namely, if follow is a very strong kind of follow, namely that it's guaranteed, so if the conclusion is guaranteed by the premises, if we assume that the premises are true, then this gives you a kind of deductive argument. But if follow is a little bit less strong, and we say that follow is just highly probable, then that is going to be a kind of inductive argument. And don't worry, we're going to go through each of them very carefully in this video. So let's start with deductive arguments. Okay, a deductive argument is one in which the conclusion is supposed to be guaranteed from the premises, right? So this guaranteed is very strong. Let's look at what it means for a deductive argument to be intuitively good, or at least one notion of good. And this is called validity. An argument is deductively valid if and only if it's impossible for the conclusion to be false given that the premises are true. And we say that an argument is invalid if it's not valid. So not being valid means that it is possible for the conclusion to be false given that the premises are true. So note that here we have this guaranteed is very strong. It means if the conclusion is guaranteed, it means that it cannot be false if we assume that the premises are true. Okay, again, this might be a little bit of a mouthful, so let's look at some arguments and think about whether they're valid or invalid. This is my favorite example. So let's look at the cats in Irvine. All cats in Irvine are indoor cats. Piper is a cat in Irvine. Therefore, Piper is an indoor cat. Is it valid? Yes or no? Well, yes, because, right, if we assume that the premises are true, if we assume that it is in fact the case that all cats in Irvine are indoor cats, and we assume that Piper is a cat in Irvine, then it's impossible for Piper not to be an indoor cat. Why? Because let's try to think. Is it possible for Piper not to be an indoor cat and the premises to remain true? Well, let's say Piper is an outdoor cat. Then it wouldn't be true that all cats in Irvine are indoor cats because Piper is a cat in Irvine and we said she's an outdoor cat. So that wouldn't be possible. So this argument is valid. Now note that the premises are false. It's likely not true that all cats in Irvine are indoor cats. I think I've seen stray cats around here. And it's definitely not true that Piper is a cat in Irvine, or at least not the Piper that I'm referring to. Yet the argument is still valid. So how can we do this? Well, remember the definition of validity. So it's deductively valid if and only if it's impossible for the conclusion to be false, given that the premises are true, or assuming that the premises are true. So what we're doing is we're really saying, okay, we don't care about what's actually the case. We're just evaluating the argument for its argument's sake. So logic is a study of the link between premises and conclusion of an argument. It is not the study of the truth of the premises. Again, that goes to science and observation. If the argument is valid and has true premises, then the argument is called sound. So a sound argument is really good. Now, again, going back to our example, is that example sound? Well, no, because the premises are in fact not true. They're false. Okay, so let's keep on going, but I need to go up, right? Okay, so let's look at 4 possibilities of deductive arguments, of what can happen. And over here we have that the reasoning is valid or invalid in the rows, and in the columns we have that all the premises are true and some premises are false. Let's look at the first square. That's the best case scenario, right? If the reasoning is valid, that means the logic is good, then all the premises are true, then that's a sound argument. That's the best case scenario. That's the best kind of deductive argument you can have. However, if the reasoning is valid, but some of the premises are false, then it's still valid, so it's not completely terrible. But you probably want to take the conclusion with a grain of salt or not believe it at all. For example, the cat example that I told you. So I put this with a check mark and an X because it's good in the sense that it's valid, but it's bad in the sense that the premises are actually false. Now, if the reasoning is invalid and all the premises are true, then that's not great either. That's almost worthless. And that's the example that I give you where I just told you a bunch of random true facts, right? It's not an argument because the statements aren't related to each other. And if the reasoning is invalid and the premises are false, then that's just total nonsense. So yeah, that's just nonsense. Okay, so let me go back down and we can look at another example. Okay, so Bruna, the name of my late grandmother, is 100 years old and has arthritis and is generally unable to walk more than 100 meters without sitting down. Okay, so she's unfortunately very old and not in the best health condition. Therefore, Bruna will not run a marathon tomorrow. Is this a good argument? Seems to be a good argument, right? Now, is it a valid argument? Well, the conclusion does seem impossible. So is it a deductive argument? So stop this video and think for a second why you might think it's a deductive argument or why you might think it's not a deductive argument. Okay, spoiler alert, it's not a deductive argument because here the notion of possibility that we care about is a little bit different. The sense of impossibility that we care when evaluating deductive arguments is logical impossibility. It's not a kind of physical impossibility. I can guarantee you that Bruna cannot run a marathon tomorrow. Well, first of all, she's unfortunately not alive, but if she were, I could also promise you that'd be in some sense impossible. It'd be physically impossible. But the sense of logical impossibility that we care about is one where if we suppose that the conclusion is false, it would imply a contradiction of the premises, right? But if we go back to the Bruna argument, if we assume that the conclusion is false, right, and the conclusion was Bruna will run a marathon tomorrow, will not run a marathon tomorrow. So if we assume that's false, it means that we're conceptualizing that she will run a marathon tomorrow. It doesn't imply a contradiction of the premises that she's 100 years old, that she has arthritis, etc., right? In fact, there are some cases of 90-plus-year-old people that run marathons. So this sense of impossibility is not one of physical impossibility, but of logical impossibility. Another way of understanding this distinction is that deductive arguments flesh out, or at least deductively valid arguments, flesh out what is already implicit in the premises. So in some ways, in deductively valid arguments, you're not saying something completely new. You're just fleshing out what's already there in the premises. So let's look at this example, where it is raining outside, and it is cold outside. Therefore, it is cold outside. Now, this is a deductively valid argument. If it's true that it's raining outside and that it's cold outside, it's impossible to conceptualize that it is cold outside without reaching a contradiction in the premises. So to reiterate, in a deductively valid argument, everything in the conclusion is already stated in the premises in some way. And mathematical theorems are in a sense like this. You have a bunch of premises and you kind of just shuffle them around and play around with them such that they give you perhaps a surprising conclusion, but one that doesn't go above and beyond what's already stated in the premises. Okay, so let's look at another example. Is this argument valid or invalid? In August 2024, a UCI student, Ryan, goes to the student health center with a cough, fever, and muscle aches. And a week ago, Ryan was at a family gathering in which 3 out of 5 members later tested positive for the virus, that is, for the COVID virus. Therefore, I might conclude, Ryan has COVID. Is this argument a deductively valid argument? So, before jumping to this conclusion, think to yourself, well, is it possible for Ryan to not have COVID, that is, for the conclusion to be false, yet for all the premises to remain true? And of course that's possible, right? We might imagine that Ryan ate something that wasn't good anymore. We might imagine that Ryan just got the regular flu instead of COVID, etc., etc. So this argument is invalid. However, do we think it's likely that Ryan has COVID? Well, I would think so. Circumstantially, it seems like there's a pretty good chance that Ryan has COVID. And it seems like this argument is invalid, but it still seems pretty good. So calling arguments just valid or invalid might be quite limiting. Okay, so here's a question for you. Are the conclusions in scientific papers the sort of statements that are guaranteed by the premises? So in a scientific paper, you might see experiments, scientists conducting experiments, and then they might make an argument for why that experiment should be generalized. For example, I might run a trial on a particular vaccine, and it works on a small group of people, so I might conclude, well, this probably works for the general population. Right, this is very simplified, but basically that's a very, very abstract way of seeing how science works. Now, is such a conclusion guaranteed by the premises, right? That I run say that the experiment gives you the particular results you want. That's true. That all the setups are okay. That's true. And then the conclusion is the generalization. Is this a kind of deductively valid argument? Well, generally, no. They're not deductive arguments, right? They're inductive arguments. The conclusion is likely, well, depends on the scientific paper, but if it's a good one, the conclusion might be likely, but it's not guaranteed in the way that's required for a deductively valid argument. And this is why the class is called an inductive logic class, because we're going to be concerned with the logic of inductive arguments. So let's look at inductive arguments now. Okay, so an inductive argument is one in which the conclusion is not supposed to be guaranteed from the premises, right? In a deductively valid argument, the conclusion is guaranteed from the premises. But a good inductive argument, we call it inductively strong. And it's inductively strong if and only if it's impossible for the premises to be true and the conclusion false. And so this is the same machinery that we do to determine whether an argument is deductively valid. We take the conclusion and we say, okay, is it possible, or is it likely in this case, for the conclusion to be false if all the premises are true, if we assume the premises are true. And this is going to be a little harder to determine, right? Because it's easy to determine whether it's impossible, but whether it's likely, right? Different people might disagree, and this is what we're going to look at more. But this isn't it. We also have a second line, which is just that the argument is not deductively valid. And this is just to differentiate between inductive and deductive arguments. Because if the argument is deductively valid, then it's not an inductive argument. It's just a deductive argument. Okay, let's look at some examples. So how about this one? 98% of climate simulations predict the Earth will heat at least by 1.5 degrees Celsius by 2050. Therefore, the Earth will be 1.5 degrees hotter in 2050. This is clearly not a deductive argument, right? It's very conceivable that our climate simulations are just wrong and made some fundamental mistake. So it's not a logical impossibility. But it seems very improbable that if we have all this science behind climate change, it's not just simulations, but if the premise is true, if it's true that 98% of these simulations predict that it'll heat by 1.5 degrees, then we have good reasons to think that the Earth will actually be 1.5 degrees hotter in 2050. But it's inductive because it's not guaranteed. So I should say something here, that inductive arguments are risky. They're risky in the sense that they're not guaranteed. And what inductive logic is going to allow us to do is to kind of quantify that risk. Okay, let's look at another example. This is the SST building in Irvine, where the Logic and Philosophy of Science department is located. So most days, this is the argument, most days in August are hot in Irvine. Today is August 8th, hence it's hot in Irvine today. Again, this is an inductive argument. It's possible for today not to be hot, right? Because it's possible for it to immediately get really cold, even though most days in August are hot in Irvine generally, and that today is a day in August. Okay, so unlike in deductive arguments, the conclusion of an inductive argument makes a claim that goes beyond what's in the premises. So this is the risk, right? Remember that in deductive argument, you're kind of just shuffling around the premises to figure out if the conclusion is already kind of in somewhere in the premises. But in an inductive argument, you can't do that. The inductive conclusion is saying something beyond the premises. So this was an example I gave earlier. So suppose that I make a clinical trial for a vaccine and that 10 out of 100 vaccinated patients got infected with the virus and 90 out of 100 of unvaccinated patients got the virus. And so you might conclude something like, well, the vaccine is effective in preventing infection. Right? That's not implicit in the premise of the argument. You're making a step beyond. That's the inductive step or the inductive risk. So you're going from observing particular instances, like an experiment or many experiments, to making conclusions about the future. And these are called generalizations. Okay, let's look at the difference between deductive and inductive arguments. They're different in that the conclusion of a valid deductive argument cannot make claims that go beyond information already contained in the premises, whereas conclusions of inductive arguments make claims that go beyond information already contained in the premises. A good deductive argument is one that's valid, whereas a good inductive argument is one that's strong. And so they differ in degrees of strength, right? Because the deductively valid argument is kind of the strongest kind of argument you can have. The conclusion is guaranteed from the true premises. Whereas an an inductive argument might be more or less strong, right? It might be, you might have some confidence that the vaccine is good at preventing the virus, or if you run 20 more experiments that all kind of reinforce the conclusion, then you'll have a stronger belief that the conclusion is correct. So you might look at it, this is taken from the book, that the strongest kind of argument is a deductively valid argument, and then you have different degrees of inductive strength, and at some point the argument becomes worthless. So here's a little chart of kind of fleshing out the kinds of arguments. We have two types. We have deductive and inductive. Deductive arguments can be valid or invalid, whereas inductive arguments can be strong or weak. Okay, so before ending this class on arguments, let's look at this notion of probability. So far, I've been quite imprecise when saying that the conclusion is likely, or that's improbable, or that it's probable, right? I've just been relying on your intuitive understanding of what likely or probable means. So what this class is going to do is make this a little bit more precise. So the inductive probability of an argument is the measure of its inductive strength. In other words, it's the measure of the strength that the evidence gives for the conclusion. So the inductive probability of the argument as a whole is how strong the link is between the premises, or the evidence, and the conclusion. Let's look again at some examples just to pump our intuition. So suppose that Google tells me, I look on my phone, whether it's going to rain tomorrow, and says that there's a 95% chance of rain tomorrow. The Weather Channel says that there's a 90% chance of rain tomorrow. And the LA Times also tells me there's a 95% chance of rain tomorrow. So I conclude it will rain tomorrow. So the evidence, or the premises, is, you might think, all the evidence I've collected through looking through the 3 different websites. And so I infer a conclusion that it will rain tomorrow. And this argument has intuitively a high inductive probability. Now suppose I look at the same websites and they tell me that there's a 5% chance of rain tomorrow, or 10%, or 5%, and I still conclude that it will rain tomorrow. I hope that you have the intuition that this has a very low inductive probability. Okay, so I've talked about the inductive probability of arguments, but we can also assign probability to statements. And this is what we might call the epistemic probability. So for example, I might believe with 90% chance that it will rain tomorrow, instead of believing that it will rain tomorrow is just true or false. I might have some degrees of belief in that statement. And so just like truth applies to statements, epistemic probability applies to statements. And just like validity applies to arguments, inductive probability applies to arguments. And so what we're going to try to do in this class is to find the relationship between epistemic probability of the statements and the inductive probability of the argument. Just like deductive logic looks between the relationship of the truth of the statements and the validity of that statement. Okay, so finally we can look at what is an inductive logic, right, as we finish our first week. An inductive logic is a formal mathematical system that gives us a precise definition of inductive probability and rules for evaluating inductively strong arguments. So just like deductive logic, which we've briefly touched on with the truth tables, just as deductive logic gives us rules to evaluate whether an argument is valid or invalid, an inductive logic is going to give us rules for evaluating whether an inductive argument is strong or not. And basically what this is going to do is it's going to give us a tool to be able to translate inductive arguments into mathematics, use the mathematics to figure out if it's inductively strong or not, and then say, well, that argument in natural language was strong or weak. And it can be a really useful tool if it's done correctly. And next week, we're going to see some problems that might arise in constructing such an inductive logic system. And it actually brings us to some quite old questions in the history of philosophy. So I look forward to it. Thank you.